In this video, we're going to look at how to tell if two vectors are parallel. In order for two vectors to be parallel, they must have the same or opposite direction, and their magnitude doesn't matter. It can be the same or different. You only need to consider the direction. Now, this can be shown by vector A is equal to k times vector B, where k is a scalar quantity. And what this means is pretty much A differs from B by only a magnitude, and they have the same direction. So let's say that vector A is equal to 2, 4, 6, and vector B were equal to 1, 2, and 3. And from this, we can say that vector A is equal to 2 times vector B, and therefore vector A is parallel to vector B. And there's one more way to check if two vectors are parallel, and that is to consider their unit vectors. A unit vector is pretty much a vector with a magnitude of 1. And the way you can find the unit vector for any vector is to divide it by its own magnitude. Take vector b, for example. First, to find the unit vector, we need to find the magnitude of b, which is square root 1 squared plus 2 squared plus 3 squared, or simply square root 14. And now, if we divide vector b by its magnitude, we'll get the unit vector of b, which can be written like this. So the unit vector of b will be equal to 1, 2, 3 divided by square root 14. And now let's look at the unit vector of a. Doing the same thing, we first find the magnitude of a, which is square root 2 squared plus 4 squared plus 6 squared, which is equal to square root 56, or 2 root 14. And now we once again divide vector a by its magnitude to receive or to get the unit vector of a, which will be 2, 4, 6 divided by 2 root 14. And now let's consider or compare the unit vector a and the unit vector of b. So first, let's multiply in or divide the vector by its magnitude, and we'll see that the unit vector of b is equal to 1 divided by root 14, 2 divided by root 14, and 3 divided by root 14. And the unit vector of a will be 2 divided by 2 root 14, 4 divided by 2 root 14, and 6 divided by 2 root 14. And this simplifies down to 1 divided by root 14, 2 divided by root 14, and 3 divided by root 14. So we can see that the unit vector of b is actually equal to the unit vector of a. And pretty much what this tells us is that when we convert these down to unit vectors and make their magnitude the same, they're the exact same vector, which means that their direction must be the same. And from this, we can conclude that vector A is parallel to vector B. Now, let's look at a different type of problem. Let's say we're given two vectors. Let's say vector A, which is equal to 2, 4, 6. And let's say we have vector B, which is 4, and then let's say S and T, which are two variables we don't know. And let's say that the question tells us that vector A is parallel to vector B. How can we find the value of S and T? Well, let's write it that vector A is equal to k times vector B because it's given that they're parallel. So from this, we can write in the actual value of vector A, 246 is equal to k times 4st. And now let's consider, or first let's times multiply this in. So we get 246 is equal to 4k plus ks, or not plus, but ks and then kt. And let's look at the x values first. Equating the x values, we get 2 is equal to 4k, and therefore k is equal to 2. So therefore, when we plug in the value of k equals 2 to the y and z values, we'll get 4 is equal to 2s, and 6 is equal to 2t. And therefore, s is equal to 2, and t is equal to 3. So now we have found the value of s and t given that a and b are parallel.